Please wait, we will start the meeting in 2 minutes. Can you hear me? Okay, thanks for your response. So, we will revise all the assignment today and discuss the important questions regarding the exam. Okay, so let's do this. So, in the first assignment, we have discussed solar irradiance. As you know, solar radiation is important or primary source for the solar cells to receive the energy from the sun, but this energy, these photons coming toward the earth, is reflect, absorbed and transmitted by the earth atmosphere. These spectra will ask, so what is the irradiance, what is the unit? We have all discussed this. Okay, and surface irradiation of earth additionally depend on the measuring the surface height, sun, above origin, all these things. Yes. So next, irradiance on the earth with wavelength receiving on the earth surface is given as, this is wavelength increasing in order. You can see from 250, 500, 700, 750, 1000, so on and so forth. And number of photons which is highest, you can see in this range, visible. This is name is visible, infra and UV. Energy is increasing in this side because you know Hc by lambda. Lambda is increasing this side, so energy will decrease this side. So according to this spectrum, question will ask which region is suitable for the solar cell, what is the band gap, suitable band gap of the solar cell, as we have discussed, and which band gap give you highest. So why, you can see here is the highest photon as you receive on the earth surface, sunlight without atmospheric, and so many factor also which absorb the photons or emit, absorb, re-emit, transmit, reflect. Okay, then we have discussed air mass coefficient, why this is important to us. When we characterize solar cell, we generally take, generally no, we always, every scientific community measure the solar cell efficiency by this M1.5 spectrum. Air mass coefficient, air is the definition. Okay, see this length by the directly toward the any time, and this is the 1 upon cosine theta, cosine z, So please remember this formula also. Question will ask maybe. Next we have discussed elevation or altitude angles. Altitude, you can see this lambda is altitude, longitude is, sorry, this is longitude and latitude, this is this angle. Okay, so according to your option you can assign the answer. This is the angle. So any point on the earth you can find the latitude and longitude. Okay, so answer will be C. And you can also search PV Education to visualize these angles. Here is the site, you can search for that. And we have also discussed azimuthal angle. You can see what is this angle between this projection and north, between the north and angle made by the horizon plane between north south line and projection on the sun ray on the horizontal plane. This will go minus 180 to plus 180 degree, and this is the formula. And declination angle is the between the equator, and draw line from the center of the earth to the center sun, this, and this is the formula. 23.45 degree sine of 360 upon 365, and number of sum of the number plus 284, number of the day of the year, like January 26th to the end will be 26. You have to start from the January 1st. Okay, then we have discussed hour angle HRA. What is this? And this is the formula. HRA 15 degree minus LST minus 12, local solar time LST. So you have hour angle at 3 p.m. local solar time is, what will be the answer? Yes, please. Just put the LST in this equation. LST is 3 p.m. means 15. Local solar time is 15. You have to put. Okay, nice. What is the equation of EOT, equation of time in minutes for a local Goa is given, coordinates is given to you on January 26, 2026. So how you can calculate? Answer will be this C, but let's see, this is the formula, please remember this. And B is 360 upon 365 n plus 284. So n is 26, and you have to put n. First please calculate the B and n. B we will get 305.75 and 2b is double. Just put in this equation, you will find the EOT minus 12.54. so please remember this formula for exam purpose. Then maximum day length is this is the formula, 2 by 15 cosine 10 delta 10 phi. and you have the coordinates and number of 26 Jan in Kanpur will be the maximum del n. Yes, please. As we have discussed in the first assignment, you have to find and we have already calculate, I think, for 26. Phi is already given to you. We have to calculate delta. For that we have formula. From there you can calculate. You will find minus 19.97 degree. Then please put this in this equation. So this is the important equation. Please remember. Then you will simply can calculate the values. Okay. Next question, the average monthly, average daily, all these things are given to you. Now you have to calculate. Extra radiation falling on the horizontal surface. Okay, is given to you this. So now this is advanced question, but such type question if are given, then you have to please see the solution. H naught is given to you 45000, and these are given to you, and B, just put S by S naught. We have to calculate Hg. Average sunshine day per length per maximum possible sunshine is empirical constant are given. Monthly average daily global radiation would be. Okay, so this is already given to you. Average monthly hour per day per average maximum possible 0.51. Just put in this equation and please see the solution. Clear to you? Okay, so please ready for such type of question. First you have to remember all the formulas, then you will score good marks in the exam and with confidence. The requirement of the phonon during the band-to-band recombination in the indirect band is arise due to conservation of. Now we have discussed all the angles and irradiation parts. Now come to the semiconductor parts, which is direct and indirect. You know, direct, indirect, EK diagram, momentum versus energy. Just you have same K value and you have different K value. You have to reach from air to air, so transition like that. But this is transition band to band, conduction band, valence band. This is direct, this is indirect. Okay, so here K also changes and energy also changes in indirect band gap but in the direct only energy changes, delta E. Yeah, delta K and also delta E, both are changes, not equal to 0. So both energy and momentum. What will be the probability? Next question like that. probability of the finding the electron. Whatever the value are given to you, you have to just solve. So for that, let me we already solved this step, but this is the formula. Probability 1 upon 1 plus exponential e minus ef upon kt, and e is given to you e plus 3 kt. Just put the number and see the solution. These are given to you, given. So this answer will be this 0.047 in percent, for around 4.7%. okay, so please remember this formula. Next, a semiconductor material has intrinsic carrier concentration is given to you. Ni is given this. If the electron and hole mobility are this resistivity of the semiconductor. How can you find resistivity? Do you know the formula? Rho. First U for conductivity, and rho is 1 upon of the conductivity, and this is, what is this? If the concentration n e mu such type of electron for also hole mobility, electron mobility, you know this formula, and you can number of electron, sorry, charge of electron and hole charge is same. Just put e mu e plus mu h and e. This is conductivity, just reverse of this. Are you aware this for this equation? So see the solution. Here are given solution to you directly. Please see, and I sum of the movability. Just put the numbers and will you get the answer. So please recall all the formulas and learn the meaning of these symbols, whatever he used in the formula. The electron drift current in the semiconductor is due to, please answer. Why people are not joining today? Okay, so answer will be the A. Clear to you why this is? Okay, then very good. See this, at which position the band gap of the shallow trap level reside in p-type semiconductor. P or N question may be asked. Okay, so two type of semiconductor, p type and n type. P type Fermi level is toward the, this is EF for p type, you know EF for n. So shallow level is also, okay, this is Fermi level, and shallow level also near the, this p type is you will find near the valence band, and in this near the conduction band. These are the shallow levels, traps, or okay. Next question, when electric field is given to you, 12 volt per centimeter is applied across the semiconductor at certain temperature at the average drift velocity in period of electron is given to you. Vd is also in the electron mobility. Vd is given 72. Electric field also given to you. What is the formula of mobility in term of Vd and E? So Vd equal to mu into E. Please, we can apply this formula and easily you can get the mobility. Just push the number, and in whatever in the unit, please check also the unit. 12 volt, this is centimeter per second, so you have to convert this, whatever answer will ask, answer is asked in the centimeter square, so you have to convert meter into centimeter. Okay, absorption coefficient for direct band gap, so formula is, oh sorry, this is not, this is minus h nu minus Ag to the power 3 by 2, and such type of question will ask is given to you, we have already discussed. So for 1 volt and band gap is more than 1 volt, so it will be 0 because photon will not absorb, but more than 1 you can calculate. Which of the multiple recombination mechanism present, how one can determine the effective minority carrier lifetime for all the process? So what, so do you know the formula? This is directly formula based question. So this is the formula, please remember, for all the process, lifetime of charge carriers, effective lifetime of charge carriers. And this is the rate, band to band, RG center, excitons, OJ, shallow. What is the relation for lifetime diffusion length and lifetime? P type or N type? Question may ask. In general, if N, you can directly put N or P. Clear? For P type, P. Okay, so if the question is given like that, you have to find the diffusion coefficient D. So for that you have to apply the Einstein coefficient KT by E also, then you will get the your answer. Okay, so answer will you will get answer 18.3 mm. Next we have discussed answer will be this, but same time, but there is we can replace intrinsic if the this question is not for intrinsic, this is for n-type, so Ni is just equivalent to donor concentration because donor concentration is too high, or you have to find the donor concentration, you can just put the Ni equal to Nd for whatever n-type. P-type you have to replace with acceptor. Okay, so please careful for this. We have to find Nd, just calculating, and this is the answer. Clear to you? Okay, next question. A p-n junction is formed by joining. Yes, please give me answer. See, yes, we know p-type and n-type. The built-in potential in p-n junction is due to KB. Yes, you are clear. The direction of the built-in electric field in p-n junction is p to n, n to p, left to right, right to left. Answer will be B, not A. You don't know? Let me clear to you. When we say P type, hole is majority, and if there is nothing in this side, hole will diffuse this side from here. If hole is left, what will be the remaining charge? Positive is gone up. Initially is neutral, but now is negative, immobile also, negative, negative. And similarly is electron is too high, so diffuse this side, so positive will remain immobile, positive. So in the depletion region, negative, 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 this side is positive, 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 hole, electron. So electric field direction from this is N, this is P, N to P, positive to negative. This is built-in electric direction, positive in this depletion region, N to P. Clear now? Okay. Which of the device is based on the p-n junction? Transfer diode, inductor, B. Yeah, you know. And this will be the equation for diode. When p-n junction is forward while, what is the consequence? Okay, B, you are correct. In the reverse bias, no, in the reverse bias, just in the reverse bias, depletion width is increasing. Let's say this is okay. So due to this, and when alignment also, this barrier height also increases. The if the barrier height is increases, no charge will transfer from air to air, means behave as a insulator. Next question is this: what happened to the width of the depletion region upon heavily doped the N side in the diode? So answer will be C. Why? You can see the charge neutrality and the V depletion width, donor N side, acceptor P side. So depletion region width decreasing on N side and increasing in the P side, because charge neutrality is required, because we have heavily doped with N side is having higher and this is constant, that's why this will be should be decreases. And physically, if you have earlier is like that electron 3 or 4, now we have added more, so only that much, let's say before the PN junction forming, now we have too much density, so this side only needed just area, just that much area, but this side is needed 2 more to neutralize this. Number of electron is too high, one electron recombined with one hole, so P side is increasing, N side will be decreasing. Clear now? Clear to you? Okay, next question. In a silicon based PN junction maintained at room temperature under the equilibrium condition, as a P side doping acceptor is given to you, N side is doping, donor is giving, concentration is given to you, the value of the built-in potential would be? Built-in potential, can you find? You can take 2 minutes for this. Please solve this equation. Please solve. So you know the formula: built-in potential kT by q ln multiple of donor acceptor and divided by intrinsic carrier concentration. Donor acceptor is given, also the intrinsic carrier concentration is given to you. We have to just put this number, and kT by q at room temperature is 0.026 volt. So we have to put this number, answer will be this. Now clear? So please remember this formula. Okay, next question. Forward bias condition applied. This is you given, and P inside R doping in constants is given to junction potential in the diode. First find the built-in potential, then applied forward bias. We have to apply now concept of the applied forward bias then. So you know built-in potential, we have already solved this type of question. So first we will find the built-in potential, and junction is in the forward direction, that's why applied potential will minus. We have to subtract the applied voltage, whatever is given to you, 0.3 volt. So this way you can calculate. Clear? Next, the diffusion coefficient semiconductor in the carrier concentration lab is electron and holes is given. Diffusion length, electron and holes in semiconductor ratio. Now please solve this question. You know d into 2. Just take the ratio of electron and holes. Yes, please solve. Check 2 minutes. Give me the answer. Okay, yes, your answer is correct. So in this way you can calculate. Next question. These are the options. A silicon p-n junction diode consists of p-type region containing 6 into 10 to the power 6 acceptor, and p-n-type also the 20 to 10 to the power 6 donor. What will be the width of the depletion region if the applied voltage 0.4 volt? So do you know the formula for the depletion widths? So please see the solution. Depletion width 2k s mu by q and dnf, sum of this and multiple of divide by this multiple bvi and junction potential, let's say, to the power half square root. You can say ks equal to es. Move, both are symbol to present move permittivity relative. Clear this question to you? Okay, so we have to also calculate built-in potential. Okay, next question is given, but see how to we solve such type of question. The solar cell has a band gap 1.35 eV. Find the maximum wavelength for this solar cell. So what is the concept for that? We can take the energy at least equal to of the band gap. For that you can calculate the maximum wavelength. You have to need at least equal to the band gap energy to excite the electron from valence band to conduction band. So see the solution. You can please find the value. Answer is B is correct or not. How we can solve? E equal to hc by lambda. Hc is 1240. If we put in this lambda, we will get in a nanometer. If energy, we will put in the electron volt. See? Okay, correct. So such type of question may be asked. Please ready. Extra power from the solar cell can be maximized by. How we can maximize the power from the solar cell? Maximize shunt resistance, minimize series resistance. Yes, you are very good. That way we can improve our solar cell area. Shunt should be infinite. Shunt resistance should be infinite. RSH should be infinite, and series resistance this side R should be 0 this way curve. Next, let me see this question. You have operating a solar cell operate at I max is 4 amp, series resistance is 0.5. Find the voltage loss due to this series resistance at maximum power point. Series resistance, and you can apply this loss. Please calculate this. Okay, 2 volt. Yes. Next question, please. We have already discussed this too much, this question, but now please give me the answer. If you have two solar cell, band gap Ag1 and Ag2. Ag1 is greater than Ag2, and both are have under the one sun illumination. when the which of the following is true? Consider optical losses. Yes, please. A and D. So your answer is correct. So band gap give to you idea of the open circuit voltage, while available photon on the earth according to the band gap give to you the current density. Lower band gap give you higher JSC. Shunt resistance solar cell can be increased by. How we can increase the shunt resistance? Yes, please. How we can increase the shunt resistance? Defect, we have to control the defects and so non-additive recombination centered. Okay, and this is leakage pass across due to the crystal defects, grain bound pinholes, also pure junction, metallic shunt. These are all are cause the shunt resistance. Now question is, you have shunt resistance voltage, can you find the leakage current via these shunt path holes? Okay, yes, this way you can calculate. Next question is, the solar cell delivers short circuit current is 10 am under 1 am 1.5 illumination. The reverse saturation current is also given to you. The open circuit voltage neglect and internal losses resistance in the cell would be the open circuit voltage VOC. Yes, please. So we have equation kt by q ln isc by I naught plus 1. Now please solve. Yes, please answer. Are you getting? So you will get the VOC 0.665 around. Please see the solution. I got 0.77. No, this is just use ln, not log. Okay. See the solution. This is kt by q. This is 0.026 volt, and just leave this one because this number is too large. So j by j naught only you can consider. Approximate 0.65 volt you will get. Okay, next. Crystalline silicon solar cell, you have absorbed 50%. Light intensity wavelength is given. Assuming the absorption coefficient of the infrared is 11 centimeter per centimeter, the approximate thickness of the absorbed layer. Please apply this I by e to the power minus alpha t, where t is the thickness and alpha is coefficient is you already given. I by I naught you have 50%. Now please solve for t. KE. No, B will be the answer. I by I naught you have to put half. Half, and this is minus 11t, and when you solve this, ln2 is you have to find ln2, and 11t divided by 11 you will get this number 630 micrometer. So please do calculation carefully. Now clear? Next question: to improve the fill factor in high efficiency silicon solar cell, what are the way? How we can solve? How we can improve the fill factor to make high efficient silicon solar cell? Since shunt series are given here, so first focus the what should be the shunt resistance. Shunt should be infinite, series should be 0, no? So increase the shunt resistance when this is way, reduce series resistance, this is another way, and also we can use where it can contact to improve the collection. Okay, and for fill factor this is the formula, please remember also this. And Chocolate equation, this is the equation I barabar I naught e to the power I equal to I naught QV by KT minus 1. This is called Chocolate diode equation, where is the I is diode current, first saturation current IS or I naught, applied voltage, electric charge, Boltzmann constant, temperature, and ideality factor, which is we generally put 1. This is below here. Okay, next question is: following parameter does not affect the quantum efficiency of photo device. Yes, please. How we can improve the quantum efficiency? You can see, yes, you are applied electric wise. This is not affect the quantum efficiency. Other will affect. So in this way, we also can calculate. This is formula for quantum efficiency. We have already discussed efficiency. You can put the photon current, Hc, charge, and P, power, and lambda. This is next question for to you. Which of the following device characteristics are determined with JV curve illuminated PN junction solar photovoltaic device. Define parameter. Maximum power point product of VOC-JSC. Is this correct? Maximum power is BM-IM with this is less than the VOC and JSC or ISC. At maximum power, differentiation with voltage is 0, product of I into V or not 0. So please remember, maximum, this is maximum, and at maximum point this will give you 0, and for, let's say this is the maximum point. One minute, why this is sorry, white on noise. My network issue, I think. Due to this meeting is ended, let me rejoin. Wait for 1 minute. Okay, where we are here. Screen is not visible yet. Let me reshare again. Now clear to you? Guys, are you there? Okay, thank you for your response. So in this way also we can calculate the maximum voltage. You have maximum power and current maximum, V equal to, sorry, this will be this, P max equal to IM into VM. Apply this formula, you can calculate V max. Okay, next question. Open circuit voltage. What is open circuit condition? This is VOC, this is JSC, this is short circuited, this is open circuit. Here is current is 0. According to this is line for 0 current. Current on this is voltage. Voltage is not 0 but current will be 0, so A option will be correct. Okay, next question. Yes, please. This is formula based question. Under this is the equation, identity factor M is given open circuit condition. Modify as to open circuit condition at JSC. This is, here voltage is 0. A also D also. Not D. What is D? What happened to this? Let me check 1 minute. Sorry for network problem. Let me check 1 minute. Why this is happening? 1 minute. I don't know what is. Okay, so you have to solve this equation. Open circuit condition, not short circuit. So this is VOC. You have to solve for this, and J will be 0 for this. You have to solve from this equation at this point. So current will be 0, and you know the equation, JC by J naught plus 1 KT by Q. And this is next question for you. Please solve. 1 minute. Yes, please now solve. Yes, please answer. So answer will be B. We know the formula VOC KT by Q. Just put the numbers in this equation. We have already solved this type of question, I think. So let's move forward. This is next question to you. Consider PN diode of area 2 centimeter square under illumination 100 milliwatt per centimeter square, given to short circuit intensity 25, 1 volt, maximum power is 45 milliwatt. Fill factor in the diode will be. Yes, please, fill factor. So we can please see the solution. P max VOC into JSC. We can solve this in this way also. Okay, next question also, which is dependent. You have to now calculate the efficiency. So first you have to calculate the fill factor. Efficiency is just VOC JSC multiply fill factor and with respect to the input power. Please see the solution. Are you able to copy this equation or able to can solve next question such type of? Clear? Okay. Electron mobility is given. Find the diffusivity. Can you find d by mu kt by e? Please solve this now equation. This you can use this equation. Diffusivity. Yes, please. Okay, yes, you are right. So simple solution. Next, tau is given, d is given, find the diffusion length. This is also simple. We know L equal to d into 2. We have already solved this type of question. Mean free path, how we can find? So please see, first we have to calculate VTS with our velocity, and tau is given already. So v into mean free path equal to velocity into mean free time. Okay. Next, the starting material in the manufacturing semiconductor grade silicon is, sorry, my display is lagging. Yes, please, we have discussed. D. Yes, you are right. So please see this equation. Please remember, recall what is this and what is the temperature, what is the starting material, what is the yield, energy consumption. Okay. And Simon presses trichlorosilane will be used as a starting material. obtained from the metallurgical grade and use HCl and CVD chemical vapor deposition. Which statement is about purity are correct? Yes, please. Purity of the silicon, different type of grades: metallurgical grade, semiconductor grade, solar cell required purification, or whatever. So this is the purity. Please remember this purity, and further purification also required. Quartz is first reduced to metallurgical silicon, not cut directly. Next, which of the following is correct sequence for the manufacturing single crystal? How we can make the single crystal? So this is the sequence: first metallurgical grade purification, semiconductor grade silicon melting and solidification, and then single crystal. Please remember this. Next, the process used manufacturing semiconductor grade silicon is R. Name of the technique. Do you know? ABC. Float zone and not float zone. This is for semiconductor grade union carbide and cement process only. And ethyl carbonate process also can semiconductor grade. You can see in the cement union carbide, but not use Chuklovsky. Next, which of the statement for solar cell generation? So we have already discussed first, second, third generation. Now please give your response. So first generation is thick vapor. This is the problem. Then we have reduced the material cost and all. Okay, you are correct. So this is the single crystal, then polycrystalline and amorphous. Third generation improve the efficiency. Next, which of the following is are commonly used to element in the metallurgical grade impurity? Commonly used. Sorry, which are found commonly? Sorry, and displays not. Now please give me answer. Which of the following is are commonly found impurity element in the metallurgical grade silicon? Tin, zinc, calcium, lanthanum, or aluminum? D. Not aluminum and calcium. Aluminum and calcium, please. Calcium and aluminum. And also the percentage is given to you. In gallium arsenide, which dopant typically produce n-type conductivity. We have discussed this selenium, so please enter. These are the material. For p-type, zinc, Mg and carbon. Okay, next question for you. Window layer. So answer will be indium and aluminum. These are the can be used as a window layer. Okay, so further there, then we have discussed perovskite material. What are the advantage for and disadvantage? This is instability. Otherwise, it's excellent, and efficiency wise also excellent nowadays. The region of the using soda lime glass in substrate. One minute. In fabrication, copper, indium, gallium, selenide, solar cell is our. Yesterday, I think we have discussed these questions, so please recall. So soda lime helps the passivate the surface, also the improve the texture. Okay, next. Which of the following is are critically? What are the issues in the DSCC, disynthesis solar cell? Yes, please. Liquid dye, as you know, is the problem. Also, electrolyte degradation. So please remember, okay? Use of liquid light and this is the structure of the DSCC. Which of the following are desirable DSCC used in? The answer is strong absorption visible in spectrum, good acronic semiconductor surface, and fast injection into TiO2. These are the desirable. Band gap should be low. Next question, bulk heterojunction have superiority over the bilayer organic solar cell. So we know better dissociation and better interfacial contact. Okay, which are the problem? The organic. Starting source surface in window layer deposition. Please remember. So this is this for starting cadmium is SeNH2 all twice. Please remember this equation also. Okay. Which of the following is in polypyrrole based organic solar cell dopant use? Yeah, you are good now. So please remember this is also, these are the dopant which we have used. The photoelectrode used in DSCC solar cell. So as you know, nanostructure TiO2 and ZNO will use. Yes, you are correct. So we cover all the 8 assignment and concept based question, mostly numerical. So such type of question may, may be asked. So please remember all the formulas or little bit the dopant which are used, window layer, type of generations, solar cell, and type of solar cell, DSCC, CUJS, 6 perovskite, silicon, most important silicon are generally, and based on their question. Direct indirect semiconductors, and first chapter is irradiance, angles. Okay, so all the best for your exam. If you have any query you can ask, or you can email me if you have any doubts furthermore. Okay, so thank you and all the best. Thank you. Prepare well, solve the numericals such type of, and clear all assignment, recall the lectures, then you will definitely will score good marks. Okay, best of luck. Thank you.